All right. Probability and statistics. We're looking at probability rules. Probability rules. This is our first rule we're going to be looking at. It has to do with the probability of A and B. Probability that A and B both happen at the same time. That's going to be the probability of A plus the probability of B minus off the probability of A or B. The best way to maybe explain this would be to draw a Venn diagram. And in this Venn diagram, this represents A happening, and this represents B happening. Now, maybe what we could say is A could be the probability that you choose someone at random is a woman. So this is a woman. And then this could be a probability of someone that has the coronavirus, maybe. And so to help understand this, if I was to shade this one, this is the probability that someone selected as a woman. And then shade this one. This is the probability that someone has the coronavirus. Okay? So now you can see the probability of A and B both happening. That's this part right here in the center that's shaded by both shadings. See, this right here is shaded by both. So that's A and B. Okay, it equals the probability of A, which is this whole circle, plus the probability of B, which is that whole circle. And so when you add these two together, this part right here, you're adding it as A, but you're also adding it as B. So you're adding this thing here twice. So it's A plus B, but then you got to minus off the A or B, which A or B is anything here that's shaded at all. So this, all three parts of these is A or B happening. And so if I minus those off, I end up with just the A and B. I hope that makes sense what I'm trying to say. Now, you could add this to both sides of this equation and then take this and subtract it from both sides, and you could end up with this. Probability of A or B equals the probability of A plus the probability of B minus off the probability of A and B, which is the same equation essentially. Now another one we're dealing with is the probability of A given B happens. Okay? The probability of A given that B happens. That's going to be the probability of A and B divided by the probability of B. So it's A and B divided by just B. Now what this means is this is the probability that A happens given that B happens. So what we could say here is, suppose we select somebody at random up here. And what's the probability this person we choose at random is a woman given that they have the coronavirus. So we know it's in this coronavirus. So what's the probability that it's a woman given that this person has coronavirus? So that's going to be the probability of A and B, which is just this part right here, divided by the probability of B, which is this whole thing. We know it's got to be in B because it's told that it's given that B's happened. So it's probably of A given that B happens. So it would be just A and B divided by the probability of B. And of course, you can change this around. You can multiply both sides by the probability of B, which would give you this. If I multiply both sides by the probability of B, I would have the probability of A given B times the probability of B equals the probability of A and B. So you could do it either way. And then one last thing we're going to have on here, and this is real simple. The probability of A complement. Now what this is 1 minus the probability of A. Now the way to explain this is suppose I shoot free throws and I make 75% of them. So the probability that I'm going to hit my free throw is 75. Well, what's the probability that I don't hit my free throw? Well, it's going to be 1 minus 75%, which would be 25%. So the probability of the complement of A, which is A not happening, would be 1 minus the probability that A does happen. So that's pretty simple there. Well, we're going to take these rules and we're going to apply them to this sheet here. Okay? So if you look at this first question here, if probability of event A occurs during an experiment is 0.7, so the probability of A happens is 0.7. Okay? What is the probability that event A does not happen? All right, you're talking about the probability of A complement. Okay? What's the probability of A complement? Well, it's going to be 1 minus this. So I do 1 minus 0.7, which is 0.3. All right, so that's real simple. Look at number 4 here. Sleep apnea affects 18 million individuals in the United States. Assuming there are 304 million people in the United States, what's the probability that an individual chosen at random will not be affected by sleep apnea? All right, so the probability that a person has sleep apnea, well, that's going to be 18 over 304. Okay, so that's probably if someone having sleep apnea. Now, what's the probability that an individual chosen at random will not be affected by sleep apnea? Well, it's going to be probability that a person does not have sleep apnea. That's the complement of this. So that's going to be 1 minus 18 over 304, which is going to be 86 over 304. And that'd be your answer right there. Okay. Now, what about down here in some of these? These are just, you're pretty much just going to put these in this the equation right here. You're just going to use this equation right here, put those in. So it says find the probability of A or B. All right, so A or B, that's going to be the probability of A, which is 0.49, plus the probability of B, which is 0.52, minus the probability of A and B, which is 0.17. So you just punch this in the calculator. So it's going to be, let's see the calculator. All right. 0.49 plus 0.52 minus 0.17 is 0.84. Okay, so that's all you're doing is just using that formula. Let's do, let's see here, just do 13. Probability of A, probability A or B, probability A and B. All right, now find the probability of B. All right, so if you use your equation here, probability of A or B equals probability of A plus probability of B minus probability of A and B. All right, and if you put everything in, you know, probability of A is 0.4. So right here, this is 0.4. Probability of A or B is 0.9 over here. Probability of A and B is 0.1. But right here, we don't know this. So basically, you're just going to solve this equation. So if I add my like terms here, I'd have 0.9 equals 0.3 plus probability of B. And I would just minus 0.3 on both sides. I get 0.6. There you go. Okay. Now down here, let's look at 16. Jason attends his high school reunion. Of the attendees, 50% are female. Common knowledge has it that 88% of people are right-handed. Being a left-handed male, Jason knows that of a given crowd, only approximately 6% are left-handed males. If Jason talks to the first person he meets at the reunion, what's probably that person is is male or left-handed. All right, so what's the probability that the person is male or left-handed? Well, that's going to be the probability that he's male plus the probability he's left-handed minus the probability he's male and left-handed. All right, the probability he's male, well, it doesn't say anything about that, but what it does say is 50% are female, which means 1 minus 50% is 50%. So this is 0.50. What's the probability that someone's left-handed? Well, it doesn't say anything about someone being left-handed, but it does say 88% of people are right-handed. So if they're not right-handed, they'd be left-handed. So it's going to be 1 minus 0.88, which is 0.12. So this is 0.12. Minus off the probability that they're male and left-handed. All right, right here. What does it say here? Only approximately 6% are left-handed males. So that's 0.06. 6%. And there you go. You just add these up. So 0.50 plus 0.12 is 0.62 minus 0.06, which is 0.56. There you go. So that's what you'll do on these. All right, let's go to the back side of this now. All right, now we're doing some conditional probabilities. All right, so we're going to revert back to this right here. Probability of A given B times the probability of B equals the probability of A and B. Or, let me write up here. Probability of A given B equals the probability of A and B divided by the probability of B. So it's A and B divided by B. If you reverse these, then you'll reverse these, and which this second one will always be what you're dividing by. Okay? So you're just going to plug these in and use the formula just as well. Let's do 22 here. It says the probability of B is this, probability of A and B is that. Find the probability of A given B. All right, right there. The probability of A given B is going to be the probability of A and B, which is 0.4, divided by the probability of B, which is 0.5. If I divide that, I get 0.8. Okay. We'll do one more. What about 25 right here? 25. Find the probability of B given A. All right, the probability of B given A is going to be the probability of B and A. So that's right here, A and B, divided by the probability of A, which is right there at 0.62. So let's divide those. All right, so let's see here. 0.38 divided by 0.62, and I get, I had something on there, didn't it? That was 0.38 divided by 0.62, 0.6129, so let's 0.61. Okay. Now, as we get down here, number 28. Juan lives in this large city, commutes to work daily by subway or taxi. And what I'm going to do is I'm going to change these numbers because I'd like for you to do this problem. So what I'm going to do is he takes the subway. I'm just going to change this to 70% of the time because it costs less. And he takes a taxi the other 20%. Now, this would have to be 30 now. So let's put it right here, 30%. Okay. When taking the subway, he arrives at work on time 70% of the time. All right, we'll change this to 80% of the time. Whereas he makes it on time 90% of the time when he's traveling by taxi. We'll leave that one. All right. So now it's asking for these probabilities. Okay, so here's what you have, and we'll try drawing this out in this space. Okay, so here's one. When he goes to work, he's either going to take the subway or he's going to take the taxi. It's probably helpful to draw out this little tree diagram. So he's going to go subway 70% of the time, so that's 0.70 here, whereas 0.30 down here. Okay, now remember these numbers are different. I changed them. Now, when he takes the subway, okay, when he takes the subway, he arrives at work on time. I changed this to 80% of the time. So when he takes the subway, he's on time 80% of the time. I changed it to. So that's 0.80. Which means he's not on time or he's late 0.20% of the time. Maybe I should put that here. Yeah, I should put those there. Whereas if he takes a taxi, all right, he's on time 90% of the time, it says. Makes it on time 90% of the time. Which means if he takes the taxi and he's late, that'd be 10% of the time. Okay. Which means if I do right here, 0.70 times 0.80, 0.56, right here, this is 0.56. That means he takes the subway and he's on time. That's 56% of the time. But now 0.70 times 0.20, that's 14% of the time he takes the subway and he's late. All right, so now right here, if he takes the taxi and he's on time, 0.30 times 0.90, that's 0.27. And then 0.30 times 0.10. There you go. And now if you add all these up right there, guess what? 56, 70, 97, 100. That's 100% if you add those up. Okay, now you can just use this to answer these questions. Like right here, what's the probability that Juan took the subway and is at work on time any given day? He took the subway and he's on time. That's 50.56. What's the probability that Juan took a taxi and is at work on time any given day? He took the taxi and he's on time. That's 0.27. C, what's the probability that Juan took a taxi and is not at work on time? He took a taxi and he's late. Right there, it's 3%. And then D, what's the probability that Juan took the subway and is not at work on time? Took the subway and he's late. That's 0.14. Now, there's not a question like this on there, but what's the probability that he's on time? Any given day, what's the probability he's on time? Well, that's going to be this one and this one. You would add those two together, which is going to be, what, 80.83, 83% of the time he's on time. Okay. Now, we'll go down here. We'll do something down here. Let's see. Let's do 30. Casey gets takeout coffee. There's a 0.6% chance, or it's 60% chance, that he will also get a pastry. He gets both coffee and a pastry as takeout with probability of 0.48. What's the probability that he does take out? Okay, so I think this is a conditional probability here. So I think what we'll do is we want to figure out the probability that does take out. So the probability that does take out. Let's bring this back in to show you what we got here. The probability that does take out would be this right here. Okay. So if I divide both sides by this, probability that A given B, let me just write it right over to the side. Okay. So, well, I don't know how to show it all on the screen at the same time. I'll just write it right here. Okay. If I divide both sides by this thing right here, that means the probability of B is going to equal the probability of A and B divided by the probability of A given B. Okay, so I just divide both sides by this, and I get the probability of B equals the probability of A and B divided by this probability of A given B. Okay, now I'm going to transfer that onto this paper here. Probability of B equals the probability of A and B divided by probability of A given B. Okay. All right, so we want to figure out the probability that he does take out. All right, so if I'll tell you what, let me do this. If I transfer these things of what we're doing here to make sense, so I'm just going to do probability of T. So the probability that he does take out coffee. Let's do take out coffee, TC. Okay, that's going to be the probability that he does take out coffee and a pastry divided by the probability that he does. Now look here, take out coffee is my B, which means I'm going to have to do the probability that he does a pastry given that he does take out coffee. Okay, because this thing has to be second. Okay, now what does that mean? Okay, there, I'll put just a T here. Let's put TC. What's the probability that he does take out coffee? All right, that's going to be the probability that he does take out coffee and gets a pastry. And right here, he gets both coffee and a pastry as takeout with a probability of 0.48. Now, what's the probability that he does a pastry given that he does take out coffee? Well, right here, he gets takeout coffee. It says there's a 60% chance that he will also get a pastry, so this is 0.6 right there. Because that's the chance that he gets a pastry given that he gets coffee. See, it says he gets coffee, so you know he's doing that. But this says there's a 60% chance that he'll also get a pastry. So that's the probability of A given he's already done B, which the probability he gets a pastry given that he's done takeout coffee. And so now you just divide those. So if I divide those, see, 0.48 divided by 0.6. Oh, crap. 0.48 divided by 0.6. That's 80%, 0.8. That's the answer. Okay, and then down here, you're just putting these in the formula. So let's see here. We'll do this one here. Probability A, probability B, probability A, or find the probability A given B. All right, so that's this right here. Let's see now. If I take A given B here and I multiply both sides, I get back to what I had here on this. Okay. Now it says find the probability of A given B. So like if I take this right here and I divide both sides by the probability of B, I get this. Probability of A given B is going to be the probability of A and B divided by the probability of B. Okay, so if I divide both sides by this right here, I'll have the probability of A and B equals this over here divided by that. Okay, this is what I'm going to use for this problem here. So let me just write it out there. The probability of A given B equals the probability of A and B divided by the probability of B. Okay, and that's what I'm going to do for this problem here. So the probability of A and B, or A given B, is going to be the probability of A and B divided by the probability of B. All right, this one though, it doesn't tell you the probability of A and B. It gives you the probability of A or B. So we're going to have to use this right here. So I'll write over here, the probability of A and B equals the probability of A plus the probability of B minus probability of A or B. So I'm going to have to figure out what this probability of A and B is. All right, so the probability of A is 0.4. Probability of B is 0.3. Probability of A or B, well, that's 0.66. So now I just do this right here. 0.4 plus 0.3 is 0.7 minus 0.66. That's 0.04. All right. There you go. There's that. Probability of B is 0.3. And there you go. You just divide those. So 0.04 divided by 0.3, and there you go. 0.13 repeating, and that's your answer. Okay, so anyway, these are probability rules. You guys need help, you just yell back at me, all right? Have a great day.